Okay, boys, so I'm just going to quickly talk to you a little bit about the sine graph here and move us into solving equations that have sine, cos, and tan in them. Okay, only very simple equations, you'll be pleased to hear, and I'm going to try and make it as simple as possible for you. So on the screen there, you can see a sine curve. All right, looks like a wave, doesn't it? Often called a sine wave, in fact. I'm just going to talk you through the sine curve a little bit. So we've got an x-axis that has some very large numbers on them. Now, if you look at it, we seem to have numbers going up in 30s, and you can see 90, 180, 270, and 360, as well as a load of other numbers. But that might suggest to you that they are angles. I mean, you've used 180 degrees, 360 degrees, and so on before, and they are angles. And of course, you should know that you sine, cos, and tan an angle when you use SOCAN in right-angled triangles. So what this curve is doing is showing us the sine of lots of different angles. So if you look at 90 degrees and look at this axis we normally call the y-axis. I've called it the sine x-axis. So when we have x is 90 degrees, okay, if you do sine of 90 on a calculator, you should get 1, look. Let's see that now on this calculator. Sine of 90 is indeed equal to 1. You need to make sure your calculator is in degree mode with a little d up there, and you can do that by pressing Shift Setup and then choosing 3, just in case it's in any other mode. If we look back at the graph over here, we've got 60 degrees. Sine of 60 should be some number slightly less than 1, maybe 0.8, 0.9. Let's have a look. Sine of 60 is 0.866. And sine of 30, look, is exactly a half apparently. Sine of 30 is exactly a half. And if you look at the graph and where I'm pointing the cursor, 30 degrees goes up to the graph and then across to a half. Let's just go back to sine 60, look. Sine 60 looked like it was 0.866. Let's just move this calculator to the side a minute. Sine 60 was 0.866 something. Now you might have also noticed, look, if you look at 120, that looks like it gives you the same. So let's see, let's get the calculator on. Sine 60, there it is on the display. Sine of 120, let's see if it gives the same thing. Press equals. The same thing has come up. Okay, so those two angles sine to give the same number. Can you see another pair of angles like these two, sine to give the same number? Can you see another pair that's sine to give the same number? Well, if you look at a half here, sine 30 looks like it will give you a half, and sine 150 looks like it will give you a half. So my question is the sine of 30 equal to the sine of 150? Okay, and are they a half? Well, let's have a look. Sine 30 is a half. Sine 150 equals is a half. Yes, they are the same. So look at these two numbers that sine to give this. Look at these two numbers that sine to give a half. The same thing. What have this pair of numbers got in common with this pair of numbers? So pause the video and have a little look and think about that. What have this pair of numbers got to do with this pair of numbers? Right, hopefully you're back. What you should have said to yourself was they add up to 180, look. They add up to 180. So, in theory, sine of 10 degrees should be equal to the sine of 170 degrees. Let's see if that's true. Sine of 10 is that number. Sine of 170 is that number. Excellent. So, what would the sine of, what should we go with, 40 degrees? What will be the same as that? Pause the video, have a think about it. Hopefully you've already worked it out. It's 180 minus 40, isn't it? Let's write that down as working. 180 minus 40, so that's 140 degrees. Let's see if those two things are the same. Sine of 40 is this number. Does that correspond with the graph? Looking at the graph, look, 40 is about here. Go up to the graph, it's slightly above 0.5. This is slightly above 0.5 on the calculator. Here, look. So it's good. So there's sine of 40. Is that the same as sine of 140? Yes, it is. Okay. And you'll also notice that the graph repeats itself. So we go back to a half. We know that sine 30 is a half. We know that sine 150 is a half. There's another one over here, look, 390. That will also give you a half, as will 510. Okay, so I'm going to just extend that list now about sine 30. Sine 30 gives you a half. So does sine of 150, because they add up to 180. And so does sine of 390, sorry. And so does 510. Now let's try and bring that camera out a little bit. So the question is, how do we get from 30 degrees and 150 degrees? How do we use those two numbers to get to these two numbers? Okay, well, 390, it's not the best writing, is it? 390 is how many more than 30? It's 360 degrees along, isn't it? Okay, plus 360. And if I do the same with 150, I'll get to 510. Add 360. And hopefully, boys, that will make sense with the graph, because this bit on the graph here is very similar to this bit on the graph here. It's the same upward sweep of the curve. Okay, and the curve repeats itself every 360 degrees. In other words, the curve has a cycle or period of 360 degrees, something you may have heard of in science. So 30 degrees will be the same thing as 30 plus 360, 390. 150 degrees will be the same part of the curve as 150 plus 360. 150 plus 360 is 510. Okay, so we've got four numbers there on my writing on the right hand side. Look, four numbers there that sign to give the same thing. And the truth is, if I drag the graph over, there's two more there, there's two more there, and there's just going to be an infinite number of answers. Okay, and if you wanted to get more, you'd just add 360 onto this and add 360 onto this. And then if you wanted more than that, you'd add 360 onto those two answers, and you could keep going forever, and that would get you further and further to the right. And you could go to the left if you wanted. You could work out this one, minus 210, by recognizing that that part of the graph is the same as this part of the graph, and taking away 360 degrees. And take away 360 degrees from 30, that will get me minus 330. Let's look at minus 330. There it is. Okay? So just to summarize then, the graph kind of repeats itself every 360 degrees, and there's lots of different angles that sine to give the same number. Okay? And the cos graph is very similar. Let's see if we can get the cos graph on the screen. There's the cos graph. Okay, it also repeats every 360. It just starts in a different place. It's the sine graph, but it starts in a different place. Let's go back to sine. So we're going to do our first trig equation now, and hopefully you'll see how it links into what I've just said. So we are going to do this. Solve sine x equals 0.7 for 0 is less than or equal to x is less than or equal to 720 degrees. Okay, I'm going to need my calculator for this, and I'm going to need the graph. Okay, what this is saying is find all the angles that sine to give 0.7, and find all of the angles that are bigger than 0 and less than 720. So I want to know which angles sine to give 0.7. 0.7, go back to the graph, is about here. Okay, if I come across, it looks like it's about there. And if I go down, that looks like it's maybe 50-ish. Okay, but it won't be the only one. There's about one over here, look, which is about 0.7 high. That's going to give me 120-ish. Okay, now to help out, I can put a line on the graph at 0.7, look. Okay, that's 0.7. And you can see it's somewhat here. You can see it's here. That's just helping you see roughly where the answers are. There's another one here, look, somewhere between 390 and 420, and there's another one here. So, how am I going to get this first answer? Well, that's where the calculator comes in. Good old calculator. So, what you do is you look at this like an equation. To solve an equation, you want to get x on its own. To get x on its own, you've got to do inverse operations, okay? So we've got to do inverse sine on 0.7, something you'd have done with SOCAN. So let's do that on the calculator. Just move this up a bit. So shift sine 0.7 equals 44.42. Now I'm going to do the answers to 1 decimal place. Sometimes you'll have to do them to 2. So that's my first value of x, 44.4 degrees. And I'm going to store that in the memory because I'll need that. That's going to get me all the other answers. Shift, store, and then I press that to put it in A. So that's in A, okay? Saved in A. Now, how do we go about getting the next answer? Think about how we got from 30 to 150, 10 to 170. I subtracted this number from 180, didn't I? 180 minus 30 is 150, 180 minus 10 is 170. So, we need to do 180 minus 44.4. So 180 minus, okay, alpha A, because remember it was stored in A. 135.6, and I'm going to store that in B. So I'm going to write that down now, 135.6. So there's the first two answers, 44.4, 35.6. Now go back to this list where I got the next two numbers along. I added 360 because they're the same two parts of the graph, 360 degrees along. So I need to do A plus 360 and B plus 360. Here we go, and I'm going to store them as I go along. Alpha A plus 360 excuse me, is 404.4. Store it, shift store C, so it's stored in C, and then I need to do B plus 360. Alpha B plus 360 is 495.6. 495.6. Okay, and I'm going to store that in D. Now you might say, why is he bothering to store all these? What a waste of time. It's not a waste of time because what I'm going to do now is check that all these values sine to give 0.7. So on my calculator I go sine alpha A equals, yes it gives me 0.7, sine alpha B, yes it gives me 0.7, sine alpha C, yes it gives me 0.7, sine alpha D. And that gives me 0.7 as well. So I know that those are the four answers. They all work. Okay. You might say to yourself, have we definitely got all the answers between 0 and 720? I'd get the next answers by adding 360 onto these two. Now, if you add 360 onto 404.4, you get 760. That's terrible. If I add 360 onto 404, I get 764.4. So the next answer is just outside the range. So I don't need any more answers. There are 4 answers to that question. Okay, I'm going to do one more question because you don't have a sine graph like I do here. So I'm going to... Okay, we're going to do another quick example. So this time I'm going to solve sine x equals 0.75. Okay, we need a sketch of the sine graph. There's 360. There's 720. I should say we're going to get all the answers between 0 and 720 degrees. Okay, so just remember that that's 360. That's 720. I think I might label 180. And that's 540, I think. Label those on as well. So we're going to solve this. Where is 0.75? Well, don't forget the axes go as high as +1 and as low as -1 for a sine graph. Same for a cos graph, but we're doing sine at the moment. Where is 0.75? It's about here. So I'm going to be a good boy and get a ruler out. Draw a line going across there. Made it a dotted line. It doesn't really matter. Okay, so let's see the angles that will correspond to there. So we've got an angle there. We've got an angle there. And we got one there just above 360 and one here below, just below 540. So we need these 4 angles that the arrows point to. We get the first one off the calculator. Okay, we're going to do inverse sine of 0.75. Okay, inverse sine 0.75 is 48.59. 48.6, and I'm going to store it in A so we keep all the accuracy. Now the next number here, remember these two add up to 180, so I need to do 180 minus that. There it is, 131.4, and I'm going to store that in B. These two here are the same as these two. If you look at the 2 bits of the diagram, they're just 360 degrees further on. So the next answer is A plus 360. Let's do that. Alpha A plus 360. There it is, 408.6. And the last answer is this one here plus 360. So that's 131.4 plus 360. Before I get it, I want to store that in C. There it is. This is answer B, isn't it? A, B, C. So it's answer B plus 360. Alpha B plus 360. 491.4 degrees. There's the answers. There's no more luck because the next time it crosses the curve would be after 720 degrees. Let's store this one in D. Shift store D. Right. And then I'm going to check them all very quickly. Sine of A is 0.75. Sine of B is 0.75. Sine of C is 0.75. Sine of D is 0.75. Job done. One more example. This is going to be a little bit trickier. So we're going to do sine x is minus 0.4. Let's stick with our idea of 0 to 720. 4 answers seem to be coming out of this. Oh, that's not the best sine graph in the world, but it doesn't really matter. As long as we can see roughly what the answers are. So -1 is the bottom here. There's about halfway. I'm going to go rogue and not use a ruler. What a naughty boy. So I've got an answer here. I've got an answer here. One here. And one here, where the curve and the lines cross each other. Let's get the calculator to try and get the first answer. Shift sine minus 0.4. Minus 23.6. Now, that's not minus 23.6. Minus 23.6 would be over here. Okay, So, we've run into a little bit of a problem there. Now, it might be a bit tricky to go from this one to this one, but can you see how that one and that one are the same part of the graph? Are the same part of the graph. But this number here is going to get me all of the answers. I don't want to lose this number. So even though it's not an answer, I'm going to store it in A. Okay? I might write a little note. A is minus 23.6. Okay, so that one is awkward, but that one is just 360 degrees along from this number, isn't it? So let's leave a space for the first answer, but the second answer is 360 degrees along from this. So plus 360 is 336.4. Sorry, you didn't really see that. There it is, 336.4. And remember, I've got that stored in A. So I'm going to store this not in B, I'm going to store it in C. And I'm going to write C underneath it. I'm saving B for that one. So the question is, how are we going to get this one here? Well, there's lots of ways of doing it, to be honest, boys. One way of doing it is looking at the symmetry down here. This is 90 degrees and the sine graph is symmetrical about 90. So how far is it from 90 over to there? And that'll be the same as the distance from 90 over to there. So kind of use the symmetry of the numbers. In other words, think about a sequence. We've got minus 23.6, 90. What number goes here so that we've kind of got symmetry? Well, these are 113.6 apart, aren't they? So I will want to add on 113.6. Okay, that's one way of doing it. Another way of doing it is to realize that this little gap here, this little gap between where the graph crosses the axis and the answer, is the same as this little gap here. Okay, so this gap is 23.6 degrees. This gap here is 23.6 degrees. So I want to do 180, which is what that is, plus 23.6. That's a different way of doing it. That's what I would do, to be honest. So I'm going to do that. Now, one small problem is A is minus 23.6. Let's make it positive by doing minus answer. There it is. Okay, and I said I would do 180 plus that. There it is, 203.5. 203.6 is what it actually is. And I'll store that in B. Now that was a bit tricky, fair enough, that is tricky, but once you've got those first two there, those two are easy, really easy, because they're the same part of the graph. So to get these answers, you're just going to add 360 degrees onto these two answers. So this is B plus 360, this is C plus 360, but I don't even need a calculator. It's 563.6 degrees. This plus 360 is 696.4 degrees. Okay, I won't be able to check those perfectly, but let's check the last one because I've lost my accuracy now. If I sign it, I'm expecting a number near minus 0.4. Close enough for me because I've lost the accuracy. So then when you've got a negative sign, it is a bit more tricky. But if you use the graph and use the symmetry of the graph, it can be done.